This is inside the cockpit of NASA's Operation Icebridge, the largest airborne survey of Earth's polar ice ever flown. The scientists aboard are hunkered down in their command stations, gathering critical measurements on thinning sea ice, shrinking glaciers, and calving ice shelves. Flying in 8 to 12-hour shifts, multiple days a week, they're taking the vital signs of the Arctic. It's an unprecedented bird's-eye view of what climate change actually looks like.
Temperatures in the Arctic have been rising about 2 to 3 times the global average. So over the next century, we expect Greenland to experience a lot warmer temperatures, continue to melt, and then continue to raise sea level.
That's Nathan Kurtz, a project scientist with Operation Icebridge. He's part of a team of over 30 glaciologists, engineers, and pilots who surveyed the massive ice sheets in Antarctica and Greenland on this flying laboratory.
We probably do 60 to 70 flights per year. Then once we're up in the air, we transit at high altitude, but then we'll descend down to low altitude, so 1,500 feet. The P3 in particular, it's meant to fly low and slow.
First constructed during the Cold War to track Russian submarines, the P3 is an ideal reconnaissance aircraft for polar surveys. The crew will follow a meticulously planned flight path with specific targets in mind. The goal is to create a consistent and continuous data stream of the changing ice, bridging the gap between the decommissioned IceSat satellite and the IceSat-2 that's expected to launch in 2018, hence the name Operation Icebridge. The P3 is outfitted with a suite of instruments, and one of the most critical is the laser altimeter. It shoots out tiny green pulses straight at the ice sheet. Along with laser altimeters, there are radar instruments, GPS, gravimeters, and of course, a digital camera system that captures images of the terrain below.
We're measuring how thick the ice is in total, and then mapping what the rock structure is underneath the ice.
These tools reveal what's invisible to the naked eye, transforming Greenland's massive ice sheet into a 3D picture with incredible detail.
We're trying to figure out how the surface changed year to year to year. And so Helheim, what's called the calving front, so the end of the glacier, has been retreating for quite a while.
And out of the nearly 10 years of flying zigzagging patterns across the poles, the data points to an irreversible trend.
We've had large changes in sea ice, and this is changing the albedo of the surface. So sea ice is bright, reflects a lot of the sun's energy, but as the Arctic has been warming, we've been seeing a decrease in the amount of ice, and that in turn exposes open ocean, which absorbs more of the sun's energy.
This feedback loop is what keeps scientists like Nathan coming back to the poles for month-long missions. Retreating sea ice will increase global temperatures, which leads to widespread surface melting of Greenland's ice sheet.
The amount of ice that's on Greenland, if it were all to melt, could raise sea level by something like 8 meters, so over 20 feet.
Basically, Nathan wants to arm the people in charge of making huge environmental decisions with the facts. And all of the data collected during each flight mission is actionable. They help climate scientists more accurately predict how the poles could change in the future. Because even though the ice looks peaceful from above, there's a whole other story underneath. For more science documentaries, check out this one right here. Don't forget to subscribe and keep coming back to Seeker for more videos.